And welcome, ladies and gentlemen, dear mow217 student. This is the instruction video for practicum 4. What you see on the screen is the detail mechanical drawing for the base profile stage 1. The reason why I'm showing you this drawing is because in practicum 4 we're going to make an additional, or we're going to specify additional features on the stage 1 base profile such that it can then be named stage 2. Okay, so why that is important is only the additional features that were not specified on the stage 1 drawing are the features that you need to dimension for the stage 2 drawing. Okay, you can add reference dimensions as we did for stage 1. You can do that, but the other dimensions, other features that were specified on the stage 1 drawing, we don't have to specify them again on the stage 2 drawing. The reason why, if I can just say this, explain this, the reason why we've got a stage 1 and a stage 2 drawing, the stage 1 will be ordered from the supplier of the aluminium profiles. They've got some basic machining capabilities, so they can drill these holes and cut to length and so on and finish it off nice and perpendicular. And then we receive the stage 1 components from the supplier of the aluminium profiles. We then send the stage 1 components to an engineering shop with more specialized equipment for the features that we want to include on this component to make it a stage 2 component. All right. Okay, so what I would like to show you in FreeCAD, okay, so you need to, when you open FreeCAD, just click on this button here, start a new document. Okay, I've already done that. That's where this unnamed come from. Okay, if I click it again, you can see there's now an unnamed 2, which we don't need. All right, so I'm just going to close document. All right, so in unnamed 1, you can forget about these two drawings of these two files for the moment. In unnamed 1, we say file, import, and we want to import the step files, the stage 2 step file. Let's import that. All right, and let's also import, I just want to show you a feature. Let's import the stage 1 step as well. Okay, you're not going to have access to the stage 1, but there you can see the feature or the features that are now unique to stage 2. If I hide the stage 1 step file, you can see the features, these two holes that we've drilled here. If I hide the stage 2 and I show the stage 1, and how do I do that? I just select the file, I select it and press space bar. There's stage 1. Okay, so stage 1 had those 4 holes. It had a tapped hole over here. Okay, stage 2. Okay, if I hide, I select it, I press spacebar, I select the stage 2 step file, I open it. It now has these holes in addition. Okay, so how it will work, how this assembly is used in the Shigley hauler is the dowel gets inserted into that hole. Okay, and then what you see here on this assembly are 2 grub screws. Okay, those screws, this was an older revision of the assembly. The newer revision of the assembly has a single tapped hole here in the middle. This is the one that you've dimensioned now. So it's a change, a slight change in the design, but the functioning is exactly the same. The idea is for these grub screws to clamp the dowel so that it is secured in the hole. It can't fall out. It can't move in and out of that hole. Okay, so the functioning is exactly the same. the design was slightly changed. So we now have, and we've already done that for the stage 1 drawing. I can quickly show you again. Okay, so that's now these tapped holes. Okay, they are already there. Okay, all we now do, but anyway, the change is we instead of what I've shown you here, originally I had 2 tapped holes on each side. I changed that to a single tapped hole on each side. Okay, and that's also what we dimensioned in the stage 1 drawing. All right. Okay, so with that said, so the idea of the dowels is to align the 2 side plates on either side, and the distance between the dowels, if there is variance in that distance, we can accommodate that, because on the one side we've got a slot. Okay, yes, the width of the slot is very accurate, but the length of the slot can accommodate variance variance in the distance between the 2 dowels in the base plate. Okay, so that's something important for you to note. The rest, I think, for the base plate, base profile stage 2 is actually straightforward. Just once again, any dimensions that's carried over from the stage 1 drawing, you can make reference dimensions. You don't have to. Any dimensions carried over from stage 1, tolerance them again. Only the features that are unique to stage 2 are the features that we will dimension. Alright, so that's the base profile stage 2. Okay, so now for the second component that you will dimension, the side plate right. Okay, so what we do in our created document, we click File, Import, and we import side plate right B step. Okay, so if I open that, now you can see I've got 2 components that are visible, 1 component that's invisible. I now want to focus just on the side plate right, so I can click on this step file, press space, and now it's disappeared. I don't have to worry about it. Okay, so let's have a look now at this side plate right. Okay, the first important thing to note is that these side plates will be manufactured from polycarbonate, and the polycarbonate is applied in standard thicknesses. So we will use a 12 millimeter thick polycarbonate plate. Now, having said that, I've spoken to the supplier of this 12 millimeter thick polycarbonate plate. It's mow217 plastic, and they informed me that the thickness of the plate can vary up to 1 millimeter. So it can be between 12, it won't be less than 12, but the thickness can go up to 13 millimeters. Okay, that's a very important aspect to take consideration of. And the second thing is, I've asked mow217 plastic to manufacture these side plates. They've got a manufacturing facility as well, but the machine they have is a router, what is called a router. Okay, so we can quickly have a look at it's a CNC 3-axis router. Okay, so let's have a look at the images, and then I can show you what it looks like. Okay, so here you get the idea. What will be a good one? I can show actually any picture. Let's take this one. Okay, So what will happen is the 12mm polycarbonate plate in its standard length, which I think is 2.5 meters by 1.5 meters, something in that order of magnitude. Don't quote me, but they will put a standard polycarbonate plate on their CNC router. Okay, it will be clamped onto this table, and then what happens is there's a, let me just zoom in a little bit. Okay, maybe I should click on the image, see if I can zoom in then. There we go. Okay, so here where my mouse is, that is a cutter. That is similar to a drill bit, but that is a cutter. And it will cut all the unwanted material from the polycarbonate plate that is attached to this table. Alright, so the point here is machining is done from one side. Machining is not done from two sides. Okay, so that you must take into consideration. And then also in terms of accuracy, so you can now think this polycarbonate plate, the bed will obviously be large enough to accommodate the full size plate, which is approximately 2.5 meters by 1.5, more or less. So then they will machine as many as possible of the side plate right from that single sheet. Okay, so with that said, you can now understand that if there's a variance, and that's what I said earlier, the polycarbonate plate will not be thinner than 12 millimeters, but it can go up to 13 millimeters, between 12 and 13. So if they machine a side plate from this portion of the polycarbonate plate, it may be 12 millimeters thick. But the thickness, so the distance that you have control over is the distance from the base upwards. That distance you have control over. Okay, so we need to dimension the side plate right such that we control the distance, the depths from the one side, not from the other side or from both sides. That's actually the important thing. You cannot dimension depths from both sides of the plate. You can only dimension a depth from one side of the plate. Okay, and that's because of the way that it will be manufactured. Now, the other thing that's important that I want to mention is that accuracy-wise, you should allow for a little bit more clearance with the router, right? And that is why, if you look at this, if you look at the whole of this dowel, let me just go back quickly. It's that one. Okay, let me hide that one. So the dowel hole is now drilled into this base profile stage 2. So I've opened the manipulator workbench. I click on the caliper. Okay, the caliper, let me try again. The caliper appears. Let me try again. I click on the caliper, and I click on, so the caliper is blue, you can see, and I click on this yellow arc with a distance measured there. If I zoom in, I click on that edge, it gives me a radius of 5. So the dowel diameter is 10 millimeters. Okay, that will fit into this hole. You have to specify the correct tolerance for this hole. Alright, I'm not going to tell you what it is. You have to specify. We mentioned it in class, so you now have to know what letter and what number do we use for this hole. Okay, Right, but let me now show you. Okay, so let us highlight what we've just dimensioned and delete it. Okay, and we now go back to the side plate right. We hide the base profile stage B. Okay, now let's do the same. We once again want to measure this diameter, and now you can see the radius is 5,025. So if you multiply that by 2, it's diameter 10,05. Now I did that on purpose to allow a little bit more clearance for the fact that that plate is going to be machined on a router which isn't super accurate. It's good, but it's not super accurate. We want a little bit of clearance. But on top of that, please remember that also for this hole, you need to, that's the nominal size. The nominal size, diameter 10,05. You have to select and specify the tolerance. So, in order to do that, you need to know what letter and what number do you use to specify the tolerance of this 10,05 nominal size hole. Right. Okay. With that said, okay, once again, you can highlight your dimensions and delete them. Right, now what I also want to tell you here, if something goes wrong with the caliper, you can close it and open it again. Make sure you click the caliper, it must be highlighted. The default setting is a probe. We want to measure diameter or radius, so we have to click. The caliper needs to be highlighted, and this yellow arc needs to be selected. Right. Okay, I'm going to close that, and I just want to tell you a little bit more about this plate and the datums that we're going to select. Now, obviously, and this is a hint, the positions of the this dowel hole and this slot. Okay. Okay, let's first talk about the dowel hole. The position of the dowel hole need to be specified with the positional tolerance. Okay, and for that you need to specify at least 2 datums. Okay, so now what do we select as the datums? Okay, select the largest surface that you will use as a datum as the primary datum, and a smaller surface as a secondary datum. So I hope it is clear for you that you can select, for example, this face as the primary and this face as the secondary. Then you will have basic or box dimensions from those 2 faces, and you can control the position of that hole very accurately. Alright, and for the slot, now here you must be careful. The position of the slot can be specified in both directions. It can be specified in this, if I can call it horizontal direction. Maybe what I should do, here we go. Right, so the position of the slot can be specified in the horizontal direction. Okay, and for that we can use a tolerance. Excuse me. The position in the vertical direction is critical for us. For that we can use a positional tolerance. All right. In the vertical direction. In the horizontal direction, a plus minus tolerance will suffice, because the length of the slot isn't that critical. We can have a tolerance there, but in the vertical direction, our position, our placement of the slot is critical. So there we will once again use a positional tolerance from this bottom datum. Okay, and and I said earlier, let's select this face as the secondary datum, the bottom face as the primary datum. So the positions of these bearing diameters, if I can just rotate it a little bit, so there you can see, I'm talking about that face, and that face. I think for practicum 4, you're only specifying the location of one of these holes, because the other two are basically the same, just different dimensions, but the dimensioning strategy is exactly the same. So we will specify a basic dimension from the secondary datum, from the primary datum, and we have the position of that hole. The diameter of that hole, okay, we can measure again as before with the caliper. I'm not going to show that again. The tolerance of that hole is very important. So you need to select the letter and the number for the tolerance value of that hole. That you need to do. Okay. Now, so that's straightforward. Okay. What is also important here is the this shoulder. So the bearing will fit into this hole, and it will sit against that shoulder there in the back. Okay. And what I said earlier, so the depth of the shoulder you need to specify from one of the sides. Okay, that's important. You cannot specify a depth from one side and from the other side. For this application, all the depths need to be specified from one side, okay, which is the side that will lie flat on this face. That's our reference for, that's our datum for from which the depths will be measured. Okay, so I hope that is clear. What I also wanted to show you, yes, okay, so this, let me do this quickly. Yes, now you can see. Okay, right, I hope you can see. What I can also do, I think I can do it here. Wireframe, yes, there we go. Okay, that doesn't help me a lot. Hang on. Yes, here we go. All right, so can you see now that on the, if I can just jump back quickly, view, its draw style and shade it. Sorry, view, draw style, flat lines. Right. This is a chamfer. This is called a chamfer. It's at a 45-degree angle. You can specify the angle, but for this case it's standard 45-degree angle, and we will specify the length, and this is something you did for MGC, I'm sure about it. You specify one of the lengths of the chamfer and the angle, and for the length and the angle you need to specify a tolerance, similar to what we do in the notes. If I can go back here, break all sharp edges to 0,3 max. Okay, so I didn't specify a tolerance here, but for your chamfer you will measure the distance and say, is it whatever the distance is, plus minus a tolerance by 45 degrees plus minus a tolerance. Okay, 5 degrees is okay, I think you can, yeah, 5 degrees plus minus 5 for that angular tolerance is fine. All right. You will understand the reason for the chamfer in a later practicum. Okay, that's, I just wanted to point out that that is the chamfer. So if you want to measure that, okay, let's try and measure that quickly. So Okay, so if we click on that and we click on that, no, that doesn't work. My caliper isn't selected. Okay, let's try again. Click on that, click on that. Okay, so there you can see the X and the Z component of that skew line. Okay, you can see, as well as the length of the line. Okay, so I've given that now away. The angle, as I said, is 45 degrees. Okay, so that's quite easy. All right. Now, in the last part of the video, okay, once again, if you select those measurements and you press delete, it's gone. Okay, so in the last part of the video, what I want to do is just talk about how do we specify these holes. Those are 6 tapped holes, and there's a specific way in which we dimension those 6 holes. All right, so that will follow. Right, so we'll get back to this view. First thing to note is that these 6 holes are M5 tapped holes all the way through. So if we measure the diameter or the radius of that hole, it's 2,1. So that equates to a diameter of 4,2, slightly bigger than 4 and smaller than 5. So it's an M5 hole. Right, and there are 6 of them. Okay, so as I said earlier, we'll get back to this view to take just one more measurement. Now, I would like to show you this sketch. It's a hand-drawn sketch, so it's not extremely neat. But this is the front view of that hole into which the bearing will sit. Okay, and then you can clearly see also the 6 tapped holes around that hole. And I've indicated the center lines and what is called the pitch circle diameter. Let me just type that out quickly. PCD, or pitch circle diameter, I've also indicated with this dash dot line here, going through the centers of all the those tapped holes. All right. So okay, and what you see on the right hand side is a section view of a section that's taken through the vertical line. And so what I've indicated is the diameter of this bearing hole. You will have the size there based on your measurement, and you'll specify the tolerance using a letter and a number, and in brackets you will indicate the upper and lower tolerances for that size tolerance specification. Right, that's easy enough. You will also then, in line with this dimension line, add a leader line with a positional tolerance, diameters, whatever you decide it should be, and relative to datums, 3 datums. Okay, and those datums will obviously correspond to what you've specified in this view. I'm not showing any datums, but there will typically be a horizontal face being a datum and a vertical face being a datum. And you will have a basic or a boxed dimension from both of those datums to the center line of this hole. And so those 2 datums will appear here, be it the horizontal and vertical as primary and secondary, or vice versa. The tertiary datum will be the face on which this component is lying when you machine this hole. Okay, so that's the tertiary datum. Okay, and we'll get more exercise with selecting primary, secondary, tertiary datums. So as long as your primary and secondary datums are correct, the tertiary is not that important at this stage. We'll get more exposure to that. Right, but what I'm showing you here is now at the bottom of this dimension line, in line again with the dimension line, I've got another filled triangle, and I've indicated the center line of the hole as datum P. Okay, and you can choose any letter, it doesn't have to be P, but it's very important that the filled triangle and the dimension line, those two are in line with each other, because now I'm telling the manufacturer I'm referencing the center line of the hole. And now I can dimension the tapped holes very successfully on this section view. All I need to do is put there the dimension line. I say 6 holes, M5 by whatever the pitch is. I think it's 1 millimeter. I think so, but anyway, you can check. So M5 by whatever the pitch is. I specify the positional tolerance of the center line of each of those holes to a diameter of whatever it is you need to decide. My primary datum for this positional tolerance is P, not F. It should be P. I don't know why I said F there. Sorry about that. So let's just fix that quickly. The primary datum is P. And secondary, tertiary datums can be the horizontal and vertical. Oh, no, sorry. The secondary datum can be either the horizontal or vertical face. The tertiary datum will be the same as the tertiary datum in this case, okay, which is the face on which the plate lies when we machine it, okay. So, but anyway, so the here we need to add the pitch of this 5 millimeter. I think it's 1, but you need to verify that. So 5 by 1 positional diameter, whatever the tolerance is you decide to use. And primary datum P, which is specified here. Secondary datum is either the horizontal or vertical plane, and tertiary datum the same as what we selected here. Now, very important. I'm saying here, additionally to that positional tolerance, I'm saying those 6 holes must be equispaced on whatever the PCD is. And you will notice I've boxed the equispaced, making it theoretically exact, and I've boxed the PCD, making it theoretically exact. Okay, so that is similar to that is similar to telling the manufacturer the angle between these two holes is 60 degrees, because it's 360 degrees divided by 6 equispaced spacings, which gives you 60 degree spacings. Alright, so that's, and it's theoretically exact. And now all we need to do is measure what is the PCD. And so if we do that, if we go back to this view, our caliper is selected. So let's select snap to end point, middle point or center, and we select that one. And we select this one, and there we go. It's 45 millimeters PCD, the diameter. All right, so quite easy. I think that covers most of it. If you do have any questions, the teaching assistants will be around for the first hour and a half, after which you are on your own. So what I want to suggest is start with the end plate, or the side plate right. Start with that one, and then only then do the base profile stage 2. Okay, so that's what I would suggest. Alright, so thank you very much, ladies and gentlemen. I do hope you enjoy and that you learn something from practicum 4. Thank you for watching.